So this prac investigates trying to figure out the solubility rules. We put combinations of anions and cations together, and where we see precipitates, we can then determine solubility rules. So if we have a look at the first sheet here, we've set it up with metals going across, so there's iron, 2+ ions in all of these, etc. And now what we're going to do, down the columns, we're going to add in the anion and see if it precipitates with the cation. So first of all, we'll take a nitrate and we'll see if it precipitates with a few of these. And we're just looking for a colour like that one to show us that a precipitate has formed. That one was just some iron already in there. Okay, so we've got lead nitrate has given us a precipitate, so that can maybe help us figure out some rules. I can tell you right now that nitrates aren't meant to precipitate with anything. Next, we're trying chlorides with those 6 metals, and we've got silver chloride. There's a faint colour there for lead chloride, and on we go for some of the others. The reason we're doing this as a video, boys and girls, is because the prac itself can give you mixed results, as we've seen with this one. So rather than spend our time in class doing it, we're just going to look at the video. Makes it a little bit quicker. Alright, if we do sulfate next. There we go, lead's given us a precipitate once again, and nothing else at this stage. Alright, next is carbonate. This one will just need a drop of the pet. Alright, away we go. See if the carbonate does anything. Silver and lead, so you can definitely see a trend there with silver and lead. They readily form precipitates with a large range of things. Alright, acetate, ethanoate. Let's try this one. Once again, if you remember your solubility rules at all, we should not get any precipitates with this one. So once again, lead's given us a precipitate. Maybe we've got a very high concentration of lead, which is causing a precipitate to form. And the last one for these metals, we're going to try hydroxide. We've got something for silver, something for lead. Oh, ran out. There we go. Alright, the next lot of metals we're looking at: copper, zinc, aluminium, barium, calcium and iron. We're using the same anions, so once again we'll go down the first row with nitrates. As we mentioned before, you shouldn't get precipitates with nitrates. Look at that, what do you know? Barium nitrate. My colleagues here are shaking their heads as we do this. Chlorides. You can get a few precipitates with chlorides, but it's generally silver and lead. So they've all come up clear, which is what we expect. Let's have a look at sulfates. Sulfate should definitely give us a couple of precipitates in this one. And there we go, barium. Calcium can sometimes give you a precipitate. Just depends on concentrations. Let's go to carbonates. Copper carbonate gave us something. Zinc carbonate looks like there's something there as well. And that one, and that one, and that one. Oh, we love it. So that's a good one. 2 to go. Ethanoate. Just like nitrates, we shouldn't get any precipitates. We'll see what happens. Nothing, that's good, that actually worked. And the last one, hydroxides. Equipment malfunction. Use a drop pet. That was something there, copper hydroxide. Looks like we're getting a little bit of precipitates for a lot of these. Just going to put a bit more on the zinc and the aluminium. And there's a faint precipitate, it looks like there. There we go. Alright, that's it. So as you can see, you've got a whole bunch of results. You're meant to use those results now to figure out some general solubility rules for different cations and anions. But when you actually analyse these, as your teacher will take you through in class, We got some mixed results there, so we'll just go back to the solubility table for the rules. Good luck.